Hi everyone, let's solve this problem. Decode ways. You have intercepted a secret message encoded as a string of numbers. The message is decoded via the following mapping. 1 is mapped to A, 2 is mapped to B, and so on. 26 is mapped to Z. However, while decoding the message, you realize that there are many different ways you can decode the message because some codes are contained in other codes. For example, if we take 25, it can be 2 and 5 or 25. Similarly, we are given an example where it can represent different codes. The grouping 11106 is not valid because 06 is not a valid code. Only 6 is valid. That is one of the use cases they have mentioned. There may be strings that are impossible to decode. Given a string S containing only digits, return the number of ways to decode it. If the entire string cannot be decoded in any valid form, return 0. And let's take an example here. In this case, when they say 1 2, it can be 1 comma 2 or 12, which represent A, B and L, but here they are just asking us to return the number of ways. Number of ways is 2 in this case. That's the question, that's the answer we have to return. Now let's try to understand with this example. So let's say for example I have 2 to 6. What can I do is, so basically at any point of time we have only two possibilities. One is 1 to 9 single digits, or we have double digits numbers like 10 to 26. These are all the only possibilities. So our string decoding will happen only either for single digit or double digit, and in double digit also there are some constraints where we have like it's only possible from 10 to 26. Let's see what we can do about this. Now let's say for example I have the entire string. I can just take 2 or I can take 22. As I mentioned, it will be either single or double digits. When I take 2, I have, again I can just take 2 or take 26. So here we have already reached the end of the string, and here I can just take 6. Once I take 22, the only possibility I have is 6. If you observe, there are some subproblems which are reoccurring. For example, 6, 2. These are few of the subproblems which are reoccurring. Let's also take one more example just to understand it better. Let's say I have 2 to 6, 7. This is the use case. Let's say I have 2, I'll get 2 or 22, and then I can take 2 or 26 here, and then if I take 2 here, I can take 6 or 67. 67 cannot be taken because it does not fall under the range of 26, so we don't have to have this path. And then we have 26 is the possibility. After that we can just take 7, and in this case again we can go till 7. And when we take 22, there is a possibility of taking 6 or 67, but 67, like I mentioned, is not a valid one, so we'll take only 7. So if you see, there are again couple of sub problems which are overlapping. That is the reason because of which we are going to use a dynamic programming. So now how are we going to use dynamic programming? Let's say for example this is the string and these are our indexes. We will initially define a DP array where DP of 3, if you see, the length is 3 here, but we have initialized a length of 4 because, let me also define what does DP mean here. DP of I mean here number of ways to decode the substring or string doesn't matter, starting at I index. So if you consider index here, there are like starting at 3 means like an empty string because there is no index 3. So there will always be a one way for that. So that's what we have to consider. Now as I mentioned, it can be either a single digit or double digit, right? Either I can take a single digit or double digit. So dp of I can be dp of I plus 1 plus dp of I plus 2, and we can always take dp of I plus 1 because all the single digit characters are valid apart from 0. So we are going, whenever we see dp of string of I as 0, we are going to store dp of I as 0. That is the additional edge case which we are going to handle. But apart from that, all the single digit characters are valid. But for dp of I plus 2, it's only valid when dp of I is 1. When dp of I is 1, then dp of I plus 1 can be anything from 0 to 9. But if dp of I is 2, dp of I plus 1 can be between 0 and 6. It cannot cross it because it's like 20 to 26, and this is the validation which we need to check. So now let's try to write the code for this. Let dp is equals to new array of s.length plus 1, which we discussed, and we will fill all of the elements with 0. Then dp of s.length is equals to 1 for the empty string which we discussed. Then we will start iterating from the back. Once we start iterating, as I mentioned, if string of I is equal to 0, that means we just have to store dp of I as 0. Else we know that we have to do dp of I is equals to dp of I plus 1 plus dp of I plus 2. But for dp of I plus 2 we have certain conditions, so we will write it behind a condition. If I plus 1 is less than s dot length, and then what we'll check is s of I. If s of I is equal to 1, then it's fine, right? It is fine because we do not, it's fine because s of I is 1, then s of I plus 1 can be anything else. Or the other condition is s of I is 2, and then if this is the case, then s of I plus 1 should be between 0 and 6. So for that I am going to do s of I think there is, okay, this is the problem because of which it was not highlighting. So either s of I is equals to 1 or s of I is equals to 2, and then it contains these characters. In that case, what will we do is dp of I plus equal to dp of I plus 2, and then we return dp of 0, because dp of 0, if you see the definition, dp of I is number of ways to decode the substring starting at I. If we are at 0th index, that contains the entire string. That is the reason we are returning dp of 0 in this case. So let's try to run it up. Cool. Let's try to submit it. Cool. Now let's try to understand the time and space complexity of this. Space complexity is pretty straightforward. We are declaring an array of length n, so it will be big O of n. And if you see the code for this, we're just iterating over the string completely, and these operations are big O of one all of them are big O of one operation, so it would be big O of n. I hope the solution is clear. Thank you.